Aha. Okay, now I should be back. Thanks, Johan. I'm back. Okay. Does this work on YouTube? Ah, okay, it works. I just can't see the comments in here, I think. Ah. That's annoying. Let me see. Otherwise, I need to restart the stream. Okay, it works. Ah, no quick check. Hey, okay, okay, I see. I'm back, so I need to keep open the other window so I can see the comments on. Yeah, I can see the comments otherwise. Okay, hi everybody. So I thought let's jump into a live stream today. Let's talk about data engineering. Let's talk about what's up right now. I created a tier list for AWS services. We're quickly going to chat about this. A few of you had good topics about this, so let's see, and then talk about a few polls that I made that were actually interesting from the results. And yeah, waiting for your questions to chat and to hopefully help you a bit. So let's just start like this. Let's jump right in. Hey Brandon. I can see Brandon, Dan, Ash, Neela, Haruna, Sartak on LinkedIn. I just can't show any comments in here right now, unfortunately. So I need to find out how to be reorganized. And next time we're back to normal. Streams are going to come back. This week I want to stream every week this week, so it's going to get better. I also have, for the second camera here, I also have a second camera coming, a real good one. So about that. Book recommendations. Omar, very good question. Book recommendations. I have, so one thing that I would look into, the book from Joe Rees, the Fundamentals of Data Engineering. I think for data engineers, it's quite good. Let me bring it up. Amazon. Fundamentals of Data Engineering. Is that, yeah, from Joe and from Matt. That one makes sense to look into. Back in the day, they sent me a review copy, and I just looked into that review copy again. And yeah, I like it. It's a good book. So that thing I can definitely recommend. The others, I don't know. I don't know if there's something that fits to data engineering. The first thing would be this. I was thinking of writing one like data engineering for lazy people. That's something I have on my mind. I don't know what you guys think. Let me know what you guys think about data engineering for lazy people. Could be interesting, right? Could be something that would make sense. Maybe from a point of view of being good lazy, right? Not being bad lazy in terms of taking everything not serious and messing stuff up, but in terms of taking the interesting approach, focusing on the important stuff, and yeah, doing data engineering cleverly, right? at the core, I'm a lazy guy as well. So I hate doing extra work. So yeah, I think that could be something really, really interesting to do. And I'm going to send you a bit of a syllabus for this. Yeah, I don't actually know if LinkedIn still works. I'm getting mixed things here. I don't know. Would you choose Informatica over Airflow or Mage? These kind of tool questions are always a bit difficult. Use the tool that you like the most and that you think is fits best to the company as well, to what you're doing. And so very difficult to say. I think Informatica is more old school, right? It's more corporate, is more how should I say this? Also, I think it's more expensive than, for instance, Mage, which would be free, right? Airflow, it depends a bit of what you want to do. So do a bit of research, try it out. Airflow might be a bit different from a use case than Mage. When I think about back at Mage, like how easy it was to create ETL pipelines and organize this, that's actually not the base or the core of Airflow, which is orchestration. Yeah. Robert here says, "Hey Andreas, I enrolled in the academy a few days ago." Welcome, Robert. Liking the course so far. I'm pretty busy at work right now, but when I have more time, I'll make some good progress. Yeah, let me know, Robert, of your progress. Put this into our Discord. I think it's a very important topic to share your stuff, to get into the habit of documenting, and to get in touch with people. Yeah. Again, oh man, it's annoying that I can't see any LinkedIn comments. Anybody from LinkedIn, if you're on LinkedIn and if you want to chat with me here, I can't see any comments on LinkedIn. Just come over here to YouTube. It's running on YouTube, and we can chat there. In India, if we learn AWS Data Engine, is it worth it? It's always worth. It's always worth to learn data engineering on AWS, on Azure, on GCP. Doesn't really matter. Start with one, get into one, and then also in India you will be fine. Just a question, do data engineer and software engineer have similar skill sets, or they have different tech skills? Well, they are different from a standpoint of, okay, do you need to code? Both need to code, both need to do software or software engineering. As an engineer, the thing is you're more into data. It's more focused on data. And that is why the skill sets are a bit different. The tools are a bit different, and also that focus on working with data, transforming the data, and using the specific systems for them. It's a bit different, but at a core, in my opinion, a good data engineer needs to also be a good software engineer, because without software engineering, it's always very difficult. Always difficult. Now, there are tools like Mage. We've talked about Mage before. Are fine, very good. But even with Mage, even at ETL tools, or whenever you need to code a bit in Python, you need software development skills. You need to be handy in, okay, this is how I can solve a problem. This is how I can code. This is how I can test my code, and so on. It's it's always the same thing. You need to do software engineering for this. There is, I see one comment on LinkedIn. We use a low-code tool called Data IQ to do data engineering wrangling, but there are steps and options. You can add Python steps, and SQL and more. It's very often the case that these tools allow you to add then Python, add your custom SQL, because they have standard blocks that you can use. But at some point, you most likely want to do something very specific, and therefore you use your Python or your custom SQL parts. Absolutely. By the way, when we talk about AWS, no, let's not talk about that now. Let's talk about that in a sec. Data engineer, software engineer. Here's a good one. Transition from data analyst to data engineer. How would you suggest a roadmap for data analyst? There is a video actually that I want to watch from Ben, the Seattle data guy. So maybe we get into this. Generally, just what I tell my students. What I tell my students is this. Let me bring this up. Let me bring this up here. Where is it? Where is it? What I tell them in my academy. So, okay. So, generally, what you should look at is where are you coming from, right? It's always the important part. Get into data engineering. Where are you coming from? Are you coming from software development, or are you coming from, for instance, data analyst? If you're already a data analyst, then most likely you're coming from the data warehousing part, or working with data warehouses, working with this prepared data and BI tools, right? And that strength you need to leverage. So you need to build on top of that, right? And so what I say to my students is, yes, there is a lot of stuff here. For instance, with open source, you could go into streaming with Spark, Kafka, MongoDB, and so on, but and lose yourself in this. But as an analyst, the clever way would be to actually go towards, and I put this into tracks, go towards, let me see here, that you see my, okay, now you can see my mouse, that you go towards track C, towards the data warehousing. So you're going towards what you already know and expanding from that point on, right? So you get into, for instance, into something that everybody uses, Snowflake. Then you start with Snowflake because you already have some warehousing knowledge, Snowflake. Then you figure out, okay, how do I actually get the data into Snowflake or into Databricks? Same thing, Spark, Databricks. How can you get the data in there, and then how to transform it? You might want to get then into DBT, working with DBT for the transformations. And from there, you then expand your way towards, for instance, towards streaming pipelines, towards log analysis, and so on. You know? So that's I would come from what you know and use what you know first. You already know data warehousing, and that's the way. Don't get into streaming, don't get deep into software development, because most likely that's not what you're already good at. So leverage what you're already good at. And I think I should do a lesson for my students on that. Leverage that and build up upon that. I can see questions on LinkedIn. These are on the other monitor. In which factors ETL developer is different from data engineer? So the thing is, ETL developer, very often they work with different tools, right? They work with an ETL tool where you have your source, you have your tool, and then you feed your data through it and you put it into a warehouse or something. And it's a very narrow narrow job role when you think about it. Now, from the point of a data engineer, is usually you work with you also work with streaming pipelines. You work with reverse ETL, where you take data out of the warehouse and you put it back in into other stores like a data lake, and also because you are taking the data and preparing it for other people, for basically for the ETL developer. You most likely are going to prepare the data for this person. So it's a much wider role than just the more narrow part of the ETL developer. I think that I never was a ETL developer, so it's a bit difficult to answer this for me, but that's how I would say that's how this fits together. Data modeling. What's your opinion on data modeling and modern data stack? This whole topic, modern data stack. I know people like this. It's a phrase that people use, but really, modern data stack. What do you have there? You have your data lake. You might have a data warehouse. You might have an OLAP data store, maybe streaming batch. So the whole combination of it. But from the modern data stack, I always first think about this lake house architecture, where you have your data lake and where you have your warehouse, and basically use that together. And data modeling in these parts, or in the modern data stack, is super important, because your data needs to be modeled in the right way, right? You need to figure out, okay, my data now is going to be stored in that kind of way in my data lake. How can I optimize it for storage, for retrieval? What kind of, for search, for instance, right? And that all goes into that topic of data modeling. How can you model that in the right way, right? I think that's what you're getting at. If you don't do any data modeling, then it's going to be very difficult to work with the data. Yes, it's a data lake. Yes, it's the modern data stack, right? But either way, with data lakes, with no SQL databases, the actual modeling of the data in each step that you're doing is super important. Super important. That's why people sometimes say, "Oh, well, it's a NoSQL database, or it's a schema-less database." Yes, it's schema-less, but you actually need to figure out a schema for it before you use it, right? So that's very important. Keep that in mind. So for me, that's a very important topic. And when I think back and what I have used, and when I have worked with data that is stored in the data lake, whenever I would think back when I stored my data in a key value store, the modeling was actually the more important and the difficult stuff. And if you mess this up, then everything is messed up. Any suggestion on data ingestion tools? Did we have that? For data volumes in terabytes and daily increments in gigabytes, optimal price, performance. The first thing that always comes to my mind in this is always Spark. If you really have these big amounts of data, Spark is the one that I would look at, that I would go for first. If it's the right thing for you, difficult to say. But from a position of, Is it expensive? Of course it's, well, if you process a lot of data, of course it's going to be expensive. It's not going to be there for $5 a month. But Spark, especially like on Databricks, I think it's a good value to money ratio there. I don't know. Do you, CTC, change data capture? Look at that. Look at Databricks for this. For a large amount of data, it's difficult. I would even say not enough information for this, to actually look into Spark first. What's the best suggestion for a data engineer aspirant? The best suggestion. When you want to get into data engineering, two things: Python and SQL. Super important. If you already know SQL, you're lucky, but learn Python. In the past years, it really changed from SQL, from Java to Python. So Python and SQL, that's one thing, the development part. And also the part that I mentioned before is super important. Don't lose yourself in looking at every tool and getting into 20,000 things. Start from what you're good at. If you're coming from the software development side, try this part first from the engineering part. If you're coming from the analyst side, go from the warehouse part and then stack on top of that. If you're new to Python, might also make sense to start, for instance, with Snowflake and dbt. Super simple things, not super difficult to develop stuff there, to do transformations. You can do a lot of stuff with SQL. It's easy to set up. So start with the low-hanging fruits, start with the simple things, and then build on top of that. I think that's a very important part. Databricks, AWS, and Cloudera, PySpark, both the same, completely different things. Completely different things. You cannot really compare these two. I worked for years on Cloudera with Spark on top of it. It's not the same thing. Look into, if you're into Spark and not bound to a Cloudera platform, look for Databricks. Try out Databricks. At least try out Databricks. I have a course in the, if you're watching this, you're in the company, you need a quick start. I have a quick start in the academy. Take a look at that. This can help you, can save you a lot of time, and just try it out. What's leading cloud, and where do we have more job opportunities, in which cloud for data engineering? Well, I should make some kind of a blog post on this or something. When you look at the clouds, which clouds are the most used? AWS is the most used cloud out there. But that doesn't mean it's the one that you should go for. You should go for the cloud that in your industry, for instance, used the most, or in your country is used the most. So it's very difficult to say this one is the best. If you want to go with the safe bet, if you want to use the one that everybody uses, just go with AWS. It doesn't matter. Like, it's absolutely, it's fine. It's fine. Use AWS. It's okay. But if you want to go further, or if you want to go into a specific industry, take bit of research and look for what exactly are they doing and are they using. How do you know when you're ready to start apply for associate data engineering jobs? You never just apply for them. I think just apply and apply for these jobs. See if you get one. If you already have a bit of experience as a data engineer and or working with data, and you think you can handle yourself, do a bit of research in job descriptions, see what fits to your knowledge, and then I would just try and apply and see. I think that's, and then you're going to find out, are you ready or not? So will you be sharing any coupon code for course enrollment? Anupam, write us to hello@learndataengineering.com. hello@learndataengineering. I think my team can send you something. Just send them. I'm having something very, very special coming up. So we have a giveaway coming up. There is something coming up. I haven't mentioned it yet. It's something very special happened. You don't know it yet, but there's something coming up where we give away a few Academy members and a lot of access to our Python for Data Engineers course. What certifications do you suggest for a junior data engineer? It's always difficult. It's always for a junior data engineer. So let's see. You're a junior data engineer. That means you work for some time in a company. You have a bit of experience, like, I don't know, a year or half a year, You have a bit of experience in the cloud with AWS or GCP, and you start to understand how everything works. The certification I would go for, so the safe ones would be that you look into the ones from the cloud vendors. So a beginner AWS certification, a beginner Azure certification. And then do that. If this is easy, try out the next one. And I think these ones are fairly good. If you want certifications, yeah. The important part that I would tell you, the important part is take a look at projects. Start working on projects and start working on building a portfolio. A portfolio is super important. Portfolio is something you need to have because most things that you are going to do in your company are going to be hidden. So nobody knows what you really can do, right? So it's important that on the side at home, you start doing pet projects and you start doing your own thing and start showing what you actually can do. So that's something I would look at. It's a combination of both. Yeah. Will this session be recorded? Of course, this is always going to live on my YouTube. I'm going to leave this on my YouTube channel, these live streams. I like for me, it's important to, this is my documentation. This is my portfolio. This is my, my helper for people. Just, I'm going to leave this on and hopefully you can learn something for this. These questions, most likely we're going to make smaller cuts and then put these cuts also somewhere on YouTube. So you don't need to go through everything in one session. Between OLAP pipeline, OLTP pipeline, which among these are good to start with for data engineer portfolio? Both, absolutely. It's there's no specific one. It's the one that you like most. So depends on where you're coming from. I think somebody asked here. Didn't somebody ask from a software developer standpoint? Let me see. I think out of my didn't somebody ask this? Here, JB asked this. What's the best roadmap for data engineer transitioning from software developer to data engineer? So in that case, if you're already a software developer and you already understand how can I create code, how can I work with databases? So basically you already have the basics here down. You understand the computer science basics, right? You understand Python. You understand how SQL works. Then I would go the software developer route here, look into Docker. So you understand, okay, how can I deploy my code that I create also in containers? Important. And then I would go this, then look into platform pipeline design. How can you actually build pipelines? Why are you building pipelines this way and so on? Data modeling, we talked about this. Data modeling is one of the most important things. And then platform security so that you understand a bit how security works. From this, very often people then go the route of either ETL or batch processing and streaming. So you could look into these two tracks that I created, for instance, for my students. What I usually tell them, look into Spark, look into Kafka. So you could look into something with streaming, that you understand how streaming works. Then you already get into these tools like Spark. You work with a document store, MongoDB. Document store is very popular in the Node SQL databases. So it would make sense to go this route. Also, you could start on a platform on AWS, for instance. Start building pipelines there that you figure out, okay, how can I build a pipeline? How can I work with Lambda functions and so on AWS, so that you understand how you can transform data and the services, use the services there. So this is a very safe, I'd say safe way of doing this. The entrance, what do you do first? Doesn't really matter. It's not super important. Once you have the basics down, I would go here with something that interests me. If you have heard a lot about Spark, and then I would just go into streaming or into Spark in general. I have a Spark fundamentals course, for instance. I would start with Spark fundamentals. How can you create an ETL process with Spark? Then you could say, okay, now that you know Spark, you want to learn more about Spark. Maybe you then take that route, go towards Databricks here, right? It's a lot of preference for you. I think every good data engineer should understand streaming and should understand ETL. That's why I have this in here. AWS has ETL and has streaming in it, has warehousing in it. yeah, these things, log analysis is super important. Pipeline monitoring, these things. So I would, coming from a software development, I would first stay in my lane, stay in the software development route, and then later get into the whole warehousing thing. Yeah. Figure out the fundamentals of working with platforms and modeling, and then taking a route here. I think, yeah. Yeah, I think that's it. That's a very, very good approach. Does Golang fit into data engineering? Some people say yes, some people say no. I personally, I think if you already code, so Python is the thing that everybody uses right now, and I would go with Python, but you could also go with Go and code with Go. If the tool that is available to you has that option, why not? Why not? From a large scale thing, I think Python is the better choice, or the bigger choice. The one I would take. What makes a bigger impact on your portfolio? A few higher quality projects or a wide variety of projects? No. So first of all, everything should be high quality that you do, right? Don't do any bullshit small things. This is not the goal. You should have good projects. You should have relevant projects. If you have 4 or 5 things in your portfolio, it's already enough. You don't need to go higher. You don't need to do more. Have 4 or 5 really good things, and it doesn't always need to be a big project. Like I have in my academy, I have bigger projects. For instance, that what I showed you, this streaming with Kafka, Spark, MongoDB, and Streamlit UI and so on. Something like this is very, very big, right? It's a very big project. But also it makes sense to, but let's say you start with Databricks. Start with Databricks, document this. It's not a huge project. It's how do you get data in? How do you process data? How can you use the are they called worksheets in there? I don't remember how they called. Basically, how can you code? How can you make visualizations and so on? And that's already a project. It's already a good thing for the portfolio. You don't need to go all out with everything. So, yeah, that's why I tell my students, use the projects, use the courses as a portfolio thing. Make this your own. Use this as the base. Not like most people don't do this. You have in the academy, everybody has the code in GitHub. It's so easy to take that stupid code, fork this, or just copy this into your own GitHub as a project for your portfolio. Then you go in. You have that. You have already everything. Make this your own. Create a nice documentation, a nice README-MD file for this, where you explain what is this all about. What have you learned doing this? You could even say this was from a course. What have you learned in this? Then you go in the source code. Make the source code your own. Maybe you add more stuff to it. You create a documentation of, okay, this is what I learned in this. This is what I think about this. So people can understand, okay, you did this course. This is your documentation for this. This is your learning, or your learnings from this. This is how you might have changed this. It's super simple. In the academy, I have over 20 of these courses. I don't even know how many courses we have right now. Each and every one you could very easily take for a pet project or a portfolio project. How many people are doing this? Almost nobody. Almost nobody does this. I don't know why. And then everybody asks me, Andreas, where do I get pet projects? Which pet projects do I do? How can I build a portfolio? Hello. So already everything there. You just need to copy it and make it your own. How is this so expensive? I wanted to say. How is this so complicated? I don't know. It's nothing. Has nothing to do with you, Robert. Was a very good question. Very, very, very relevant question. But especially, Robert, were you the one who said you joined the academy? Yeah, you joined the academy. Exactly, Robert. This is what you should do. Take these, make these your own. Yeah. And use the Discord. Put it in the Discord for others. Hey, look, this is what I made out of this project. Will DevOps be automated by MLOps? What? DevOps will automated by MLOps. I don't get this. Aren't these two different things? Isn't DevOps is something very broader than MLOps, right? MLOps is more DevOps plus the ML. I quickly need to eat something. I'm back in a sec. So write me in the comments. Isn't this something different? Write me in the comments. I'm back in a sec. I quickly need to eat something. I'm back. Get this hunger flash. I need to eat something. So, isn't this the same? Let's quickly do something. Let's ask ChatGPT this. Am I the wrong user for ChatGPT? Let me see. Oh. What's the difference between DevOps and MLOps? Okay, let's see what ChatGPT says here. I want to see this. Why is this so long? In summary, TLDR. DevOps focuses on the overall software delivery and operational process. While MLOps specifically addresses the challenges of deploying and managing machine learning models in production. MLOps can be seen as the extension of wasn't this what I was saying? As the extension of DevOps principles tailored to the unique requirements of machine learning systems. Exactly what I said. So it's not that MLOps is automating DevOps. These are two different things. Or it's not replacing it. It's adding another layer to it. Should we call it layer? I think we could call it layer, right? Okay. So a few more minutes. What do we want to do? I want to watch something. Let's quickly watch something. There's one video I want to watch. And let me see. From Ben. I don't know if I should have prepared this better. Here. Let me click it. While the ads are running here. How long? Here's a good question from Anumpam. How long would it take a novice to land a job if he enrolls in your academy today? So you're knowledgeable. Either you're an analyst or a software developer, or coming from a software engineering background, or you know Python and SQL, and you want to start. So my guess is, from what I have seen my students do, and back in with my coaching days, it was even faster. 6 months, I would say. I would say 6 months is a good good number. Depends on your drive, how much time you can spend, and so on. But yeah, I think that's a safe bet. Okay. So let's try something. I'm going to start with this. I hope this is loud enough. Let me see. Okay. So let's look at Ben's video here, and I'm going to afterwards I'm going to add this. So this is from Ben, the Seattle data guy. He did actually an interesting video here. Will data engineering exist in 5 years? Is data engineering a good career choice? Let's quickly look at this. I actually want to check this out. Let me know if you can hear this.
Is data engineering a safe career choice for your future? I honestly get this question a lot where people are like, hey, is data engineering safe? Whether it's from a ChatGPT angle and honestly even far before anything that had to do with ChatGPT. So I wanted to take a video to answer the question and give some thoughts in terms of where things are going in this realm of ChatGPT and just general technology. So for those of you who don't know me, my name is Ben Rogajan.
By the way, this is something because people ask me this as well. Since the whole ChatGPT thing, people are asking a lot about, like, is this going to replace us engineers? Is engineering still a good choice if there is ChatGPT and AI and so on? So,
aka the Seattle data guy. Prior to consulting, I worked at Facebook as a data engineer, as well as several startups. So I've been doing this nearly a decade, and I love sharing my experiences with you guys as well as just thoughts. So let's dive into my thoughts in terms of, is data engineering a safe career choice? So before we start digging into answering this question, I think what's important to understand is how much data engineering has changed in the last decade. You see, when I started in the data world, I was still working on things on-prem, but Hadoop was definitely kind of picking up and maybe at its peak at this point.
Same for me. I started actually before Hadoop, or no, Hadoop was picking up, but in Germany it was still like nobody ever used it. It felt like there were no German resources, nothing. I was watching. I remember back in the day, I was watching like talks from people who were developing these kind of things. I think Cassandra was also something I was looking at back in the day. So it was a lot was on-prem with Hadoop, with Cloudera, for instance. Yeah.
In terms of, in theory, being this end-all be-all that, will solve all of our data problems because it can actually process a lot of data, in theory, considerably cheaper than the current solutions that we were using. Also at the time, Redshift had come out, so I think it's important to have that in there as well as like one of the first cloud data warehouses. So both of these solutions together.
Also, like people thought this is going to be the thing, and big data and Hadoop and so on. There were whole conferences on this where people were talking only about Hadoop, but also what he mentioned, like how were people solving this before, right? With big servers, huge monolithic things that were not very easy to use or cost a lot of money.
Together, people were like, this is it. This is what we're gonna all be doing. So in that world, data engineers and data scientists spent a lot of their time writing MapReduce jobs. They used tools like Pig and Flume and a couple other wild name tools just to try to manage all of this, and it was very chaotic.
Yeah.
And it was kind of that whole like, hey, if you ask people, back in the day, what would they want in the future, in terms of all the newer horses, they wouldn't have thought of cars. They would have just been like, well, faster horses. And that's kind of most of the tooling that was built initially. A lot of it was just built to make MapReduce easier or some of those basic things, but it really didn't solve the problem. Then someone was smart and was like, hey, maybe we put an abstraction layer on top of this. So we had Hive and Presto and honestly even Snowflake, although it's not on top of, an HDFS kind of layer, it still allows you to have like MPP or massively parallel processing managed with you not having to actually manage it, right? Like a lot of what's done, a lot of this like breaking up of work and then kind of bringing it back together, which is somewhat similar to what's happening. There's a difference between MapReduce and MPP, but the point is that a lot of that got abstracted away. So now you're no longer having to do it.
But that was actually a good thing. Like I remember back in the days with MapReduce and so on, and then the biggest problem with MapReduce was if you want to write a job and you would actually need multiple stages, right? Because you could not just you had only map and reduce, and once something came out of reduce, it needed to be stored somewhere. So there was no way of immediately adding another map stage and another reduce and so on and so on. It always needed to go down to disk, which was super annoying. This is when Spark came and it was like, oh, what? I can do this now? Amazing.
You still have a job though.
I think Spark was a bit of the part of the downfall of Hadoop back then. because the MapReduce wasn't that big anymore, and people were coming out with these abstractions, and Hive was getting bigger, and yeah, AWS and so on.
Right? In fact, data engineering continued to explode despite us simplifying some of the work that we had to do. And then another common kind of thing that data engineers would do is build their own orchestration tools. I mean, I've been at multiple companies and everyone's built their own version of Airflow 1,000 times over. I worked at a
That's actually true, very true. Back in the day, I had the same thing. We had custom tools that were scheduling our jobs, sometimes with cron, sometimes with something specific, something custom.
the company that we built our own version. So these exist. But in 2015, Airflow came out and suddenly, orchestration was taken care of. And now we've got like 4 other options, including Mage, which I'll link below because we're really trying to make it, the most popular data orchestration tool out there on the market. And there's other components that we're slowly kind of chipping away at the typical work data engineers were doing. So generally, each of these components do tend to make our work easier, but oddly, we still have more work and more of us. I think someone put this really well recently, where they referenced the fact that, Python, to a degree, is kind of this easier tool to use, right? Like it lowered the barrier of entry in terms of people who can program, because you're no longer having to deal with like learning how to do pointers or learning different data structures and algorithms. A lot of that's just done for you in Python, right? Like a lot of the heavy lifting is taken care of. So more people can now program, and now we need more people that can program because more things are possible.
That's a very, very, very good point. Like from a standpoint of coding, Python is, for instance, a lot easier than Java or any other traditional with C++, C# and stuff. I remember back in the day, my friend who came from actual mechanical engineering degree and had his PhD there, and he actually was able to very easily train himself getting into the Python scripting and working with Python. And he never got a coding course and so on. That was actually something very, very cool with Python, and that's why I like Python as well. And like you said, it fits.
And I think the same thing is going to happen here with like tools like ChatGPT that will help improve our ability to code faster. If you missed the video of me kind of poking around ChatGPT, you can see it here. But the point is, it really was helpful.
Where was it?
While I was programming, but it still didn't do everything. And it still could only really build based off of the information it had pulled from the internet. And so it kept running into these issues like, oh, well, that library is no longer used, or just other little things here and there. So there still needs to be someone on the other end that's kind of giving it the context and making sure that context is provided in a way that makes sense. Now, I'm not saying that this means that everyone's going to need to become prompt engineers or whatever that is in the future. Maybe that's kind of part of it, is we just have to learn how to actually use it. But I kind of feel like that's going to hopefully become even simpler as we improve different GPT models and other LLMs, where you don't have to be so specific or have to kind of tailor your prompt in such a specific way, but instead it can be a very kind of broad application of who can actually work with this solution. But
I want to I want to see if it gets to that point, because one thing that I always see when I hear about people coding with ChatGPT and so on, so for smaller pieces of code, for smaller tasks, it's good, or when you need some kind of a boilerplate code that you can then customize for yourself, that's something where it's really, really strong. But for larger projects, for larger like stuff where you need some understanding of how is the relation between different parts of a pipeline and so on, I think that's not very good for ChatGPT, or ChatGPT isn't very good there.
We'll see there. The point is, the tools tend to change, but there are certain components of the skill set that rarely go away. How to put these systems together effectively, how to debug, how to fix all these problems, tends to still require some level of human intervention to make sure that this all goes smoothly. Besides that, there are other layers that are coming in. Besides that, there are kind of other things I'd almost be slightly more concerned about, like the fact that in theory, there's a lot of zero EL that's going to probably be coming. We have Snowflake that's likely going to just allow you to pull data from different data sources like Salesforce, like ServiceNow, without maybe even having any form of pipeline. So now all that you need to stick on top of that is some level of SQL and business logic, and not.
The thing is always like, how does it then get the data, right? Yes, there might not be a need for a pipeline per se, as like a pipeline, but how does it work? Somehow Snowflake needs to be able to access the data and process the data. So,
Not to mention that AWS is doing the same thing with Redshift and a lot of your standard databases like Postgres. So a lot of these things will just be brought to your data warehouse. And that will honestly, in my opinion, be great. Instead of having to fiddle around with, is this a CSV that we're kind of pulling data from, or pipe delimited, or all, an API that we're parsing XML or JSON, the data will just exist as a table. And that makes so much more sense than having to, fiddle around with this little bits of code that doesn't add a lot of value. So yes, our role is just going to be continued to be pushed to the extremes. On one side, we'll be forced to work with the analysts more and try to provide more value just directly to the business. And on the other side there'll still be coding, but it'll be the harder problems that maybe, GPT or some of these other one-off solutions can't solve out of the box. No. There have always been these
yeah, exactly. What is it?
Canned solutions, canned reporting forever, and they've rarely fully solved the solution. They can do a lot, and a lot of them I think are going in the right direction where, maybe, in 6-7 years, the way data engineers operate today will be drastically different. They'll have a different title. Maybe you're not even doing the same work, but by that time, most of us who have been working for a long time will likely be managers trying to drive value, or if we're ICs, we're going to be learning these new tools, because that's part of working in technology is we must be learning new tools.
But I want to get back to that. What was that one point that he just said? These canned reports and so on. It's always the same thing. It's great that the easy stuff is automated, that there are standard ways of working with the data, but you know how it is. Always there is
every year. That's part
of you know how it is. Always it's not enough. There needs to be something custom, something very specific, which these tools or these standard solutions or these like ChatGPT kind of things can't create. Something specifically modified. That's where the engineer is going to come in. Yeah.
Part of working in technology is we must be learning new tools every year. It's kind of the painful reality. Yes, there's some base tools and base skills we can use, but all those other little skills we just have to continually keep picking up. And sometimes those tools just last for a year or two, and then we're on back to the basics, like with Hadoop, where maybe some people spent a ton of time learning how to write MapReduce jobs or operate, and manage the servers and the nodes. But now, what are they doing? They're writing SQL, or they're writing Airflow jobs, or a lot of these similar things. And it's completely ignoring the fact that some companies haven't even migrated off of some of these previous solutions. So people need help just migrating or managing some of these prior solutions. So there's plenty of work to go around in the data world. We're just further gathering more data so that we can process it via GPT. So
yeah, that's absolutely true. There are always going to be companies that are still on the old thing that need to transition to the new one, or that need to maintain something old because it's too expensive, or they don't have the people for the transformation or the transition. It's always the same thing.
So the people that can actually help manage all that chaos and all of the stuff just flying in will only likely become more valuable as things get more complex. So I wouldn't worry too much. I focus more on making sure your core skills are solid and make sure you occasionally pick up a new skill here or there so you are constantly ready for whatever change occurs. Yes, the technology world changes. That's just the reality. But I wouldn't stress too much about it. Your role will not be the same role that you're starting today in a few years. I actually recall having
That's
a professor tell us he'd never give us advice in terms of what programming language we should learn, because by the time we learned that programming language and we were out of school, it'd likely be obsolete. And to a degree, he was probably right, or at the very least, not fully right. There's still plenty of Java work out there in C++ and C# and just about everything else under the sun. So I wouldn't worry too much about, are you picking the right tool or the right coding language?
Or the right platform, AWS, Azure, and so on. We were talking about this before.
Make sure you have solid basics and you have a few good examples from your prior jobs in terms of how you actually contributed to the business, not just, how'd you solve some coding problem. And you'll likely always be employable. With that, guys, I want to say thanks so much for watching this video, and I will see you guys in the next one. Thanks and goodbye.
Very good video. Very nice video, Ben. Yeah. So, and I think it's fairly easy. You can see this fairly easy. The amount of data that is getting produced, it needs to be processed. It's steadily on the rise. We are generating more and more data, and there is no end to it. So an engineer, somebody who can actually manage that, can handle that, is always going to be needed. It's always valuable, no matter the specific tool, because most tools are the same, and it's easy to like take on another tool. Yeah, so that much for this. As I said, I'm going to come back tomorrow. I want to stream every day this week, just to because it's fun. I like it, get the hang of it, and yeah. Then hopefully see you tomorrow. I hope you had a great time. Hope you learned something. Go to Ben's video, Seattle Data Guy. Hit a like there. Here. Let me see. Can I actually like this? I need to log in. I actually need to log in to like it, but give him a like. And yeah. See you tomorrow. Bye. So where can I stop here? Here can I stop the broadcast?